Hey everybody, this is chapter 6, guided problems. So this is continuous random variables or continuous distributions. And what's different about these distributions than discrete distributions like we did in chapter 5 is that we're not just taking whole integers like in a discrete distribution, but we're taking any value between the integers. So we could be looking for instead of just 15, 16, 17 as our data points, it could be any value between that. Because it could be any value in between, in essence, we consider that there's an infinite number of variables in between any given variable. And that sounds like it's harder, but actually it's easier because when we're trying to find out the probabilities of less than something or greater than something, we don't have to worry about if I'm trying to find the probability of 3 occurrences, do I have to go down to 2 or have to go down to 3? We just would use 3 because we would consider that anything less than 3, even 2.999999999, is still part of that distribution. So I may have just confused you more. So let's just jump into these problems and see if I can make it a little easier. So this first one is, according to a recent survey, the average daily rate for a luxury hotel is $232.29. Assume the daily rate follows a normal probability distribution with a standard deviation of 22.39. Okay, so by now you've probably seen a pattern. What I try to do is start with what I know. So I'll say the average, or sometimes they would call this the X bar, right, is 232.29. That's our average. And we know our standard deviation is 22.39. And then what it's going to be doing is asking us what's the probability of a randomly selected hotel being whatever, right? So we're going to do X for our variable that they'll be asking us about, and then we'll be trying to solve for the probability, which I'll call P. All right, so the first one is, what's the probability that it is less than 252? All right, so my X then is 252, and I'm going to put in the following. So this tells us a normal distribution, so I can do norm dot dist for normal distribution. It wants our X, which is 252, our mean or average, which is 232.99 or 29, our standard deviation, and then the cumulative. Remember, if we say yes or true to cumulative, that means we're looking at all values, the probability of all values that fall below our value of X. If we were to say false, we would be looking at just the probability of just getting X. And the thing is, with a continuous distribution, the probability of getting any one point is always 0. So if you put false, if you put true, it's always going to be 0. Okay, let me show you. Okay, I lied to you. So what we're looking for is the probability of less than. It should, now I'm trying to figure out what I did wrong there. So actually, we do want, I'm trying to remember how this is set up. Cumulative. Sorry, if we put true, that's what we want to put. That's going to give us everything less than that. I think that's what I said before, but I confused myself by talking too much. Happens all the time. Maybe it never happens to you. All right. So now it wants to know what the probability of the randomly selected hotel's daily rate will be more than 256. So remember, if I put 256 in here, that's going to return the probability that it is less than 256. So remember, to find the probability that it is more than 256, we just take 1 and subtract the probability that it is less than 256. Oops, I did that wrong. Equals 1 minus less than 256. Because the probability that it is less than 256 or more than 256 will be 1 or 100%, right? So if we find less than, we can just take 1 minus that, and we can get what it is to be more than 0.1448. Now it wants to know the probability that it is between 234 and 254. So there's a couple ways we can go about doing this. I'm going to do it this way. The probability that it is less than 254. And then here I want to find the probability that it is less than 234. All right. So the probability that it is less than 254 is 0.8339. And then here I'm going to have to do another. I'm just going to copy this distribution. No, it didn't like that. Yeah, that's why. Okay, I'll show you the way I usually do it because I think this is confusing. I messed everything up, didn't I? Okay. All right, so there's our probability that it's less than 254. So what I usually do is I just leave this as like a general P and don't label everything. And then I come down here and I do the probability that it is less than 254. And I just copy this and then paste only the value right here. And then I do the same thing. And that way, all I have to do is change this to 234. I'll get the probability that it's less than 234. And then the probability that it falls between the two is just to subtract them. So the probability that it is between 254 and 234 is just the difference between the two. That one minus that one. So that's probably the easiest way to deal with that. That way I kind of leave my calculator up here untouched and I can just plug in whatever numbers I need to. All right. The last one it asks us is the manager of a local luxury hotel would like to set the hotel's average daily rate at the 75th percentile, which is the rate below which 75% of the hotel's rates are set. What rate should they choose for the hotel? So we could algebraically do this backward, but luckily, so I'm just going to call this 75th percentile. There's a function called norm.inv for inverse. And for that one, we just put our probability, which is the probability they're asking for here, 0.75 for the 75th percentile, the mean, and the standard deviation. And that will return the number we need. It wants us to round to the nearest cent. So 247.39. There we go. So there's the first problem. Let's take a look at the second problem. All right, so here's the second problem. Assume the average time between students walking up to the instructor's desk during an exam to ask questions is 9 minutes and follows the exponential probability distribution. So for exponential, we have to do this thing called lambda. So the mean or average is 9 minutes, and lambda is just 1 over the mean. So that's not too bad. In fact, it's pretty easy. It's too bad everything isn't that easy in life. Because all we have to do is remember that, right? That it's 1 over the mean. And then we're going to have an x, some number it's going to ask us for. And then we just need to find the probability. All right. So for the probability, it's going to equal, remember this is called an exponential distribution, so it's expon.dist where we have X, a lambda, and a cumulative. So what's the probability that the student will ask a question within the next 2 minutes? At 2, that's 0.1993. What's the probability a student will ask a question in the next 4 minutes? 0.3588. And again, this is why I set them up like a calculator like this, because then all I have to do is punch in a new X and I'm good. And here I'm going to say less than 5. So I'll put in 5. I'll copy and paste that value. I like to do paste the value only. I'll put in 3. I'll copy and paste that value. And so the probability that it is between is going to be the difference, or less than 5 minus the probability that it is less than 3. And that gives us the probability that it's between 3 and 5. All right, the probability that the student will ask the question in more than 13 minutes. So again, if I put in 13, whoops. If I put in 13, that gives me the probability that it's less than 13. So the probability that it's more than 13 is just going to be 1 minus that probability that it's less than 13. And that's it. So that's the second question. And then finally, the last one. All right, so this last one is a uniform distribution. So it says, assume the time required to pass through security at a particular airport follows continuous uniform distribution with a minimum time of 8 minutes and a maximum time of 12 minutes. So for these uniform distributions, we have to identify A and B, where A is the lowest possible value in the distribution, which is the minimum time, so in this case 8, and B is the highest possible time in the distribution, so that's 29. Now, some of these are just formulas. You can find them in your book that I'm using here, because there's not a function in Excel to do these. So the first thing it wants to know is, what's the function of X? And the formula, it's on page 274 in the book, is that the f of X equals 1 over B minus A. So it's as easy as going 1 divided by B minus A. That's the function. 3 decimal places. Ugh. So 0.048. The mean and standard deviation. Again, there's the formulas in your book. This is on page 276, and the mean is just A plus B divided by 2. What you're going to find is these are pretty easy math-wise the more you look at them. So what we're saying is this distribution is uniform within the bounds of 8 and 29. So what's the average? Well, it's 8 plus 29 divided by 2. Okay, that's the middle point. And then the standard deviation, it's a little weirder because they have this weird constant in it that I'm sure if I were a real mathematician, I could tell you where it comes from. It's just B minus A divided by square root of 12. So I'm like, I don't know why square root of 12, but someone smarter than me could probably tell you that. 6.0, oh, this one only wants 2 decimals, so 6.06. All right, and then it wants to know, what's the probability that the next passenger will require less than 23 minutes to pass through airport security? So I'm going to say probability of less than 23. So the tricky thing about these is, and they're not really tricky, you just have to recognize that that 8 is the bottom of the distribution and 29 is the top. And to find the probability of anything, you take the I don't know the best way to describe it, so I'll just show you. So we just take, so if it's 23 or less, we're going to say 23 minus the lowest it can go, which is 8. So that measures from the point of interest, or x, all the way down to the bottom of the distribution at 8. And then we divide that by the whole distribution, or 29 minus 8. Whoops. Let's keep this consistent. And that gives us our probability that it's less than 23. Because what we're really saying is, what's the probability that it falls somewhere between 8 and 23? And so we take the difference of 23 and 8 and divide that by the difference between the whole distribution, which is the difference of 29 and 8. And that's it. And like I said, once you do a few of these, you'll be like, oh, that's easy math. I wish it was all that easy, but at first it's a little confusing. So what's the probability that the next passenger will require more than 16 minutes? So if I say the probability more than 16, I'm going to say on the top, I'm going to say this is the high end, 29 minus 16. In other words, the distance between the high end of the distribution at 29 and x, which is 16, divided by the whole distribution, which is 29 minus 8. So the probability of more than 16 is 0.619. Finally, what is the probability that the next passenger will require between 12 and 17 minutes? So the probability, probability between 12 and 17, if I can type. So here I'm going to say the top is 17 minus 12 divided by the top end of the distribution, 29, minus the bottom end, 8.238. All right, the last one is, what time represents the 75th percentile of this distribution? So this is a little bit more confusing, okay? Because again, remember the bottom is 8 and the top is 29. So that difference between 8 and 29, which is 21, right? 29 minus 1, is the whole distribution. So if I say 75th percentile, if I say, okay, this is going to equal 29 minus 8, so the whole distribution, times 75, so 75% of that. That's going to give me the amount above the bottom of the distribution, 8. So the last thing I have to do is add the bottom of the distribution. And that's going to show me, whoa, that's not right. Something's weird there. Oh, that didn't do 0.75. There we go. So 23.75 represents the 75th percentile of that distribution. And that's it. So that's the whole guided problem. I'm sure it will help you do the rest of the homework. As always, don't be afraid to reach out if I can help, and have a great week.